So today we are going to start AWS Fundamental 2, Part 2, and in this we will be learning about load balancing, auto scaling, and elastic block storage volumes. Okay, so what is load balancing? You must be knowing that if we are having some workload wherein we want to have some kind of load balancing between multiple instances. So at that time we are using load balancing services, and auto scaling groups are being used where you need elasticity, wherein if you want to go and scale your infrastructure as and when needed, so at that time you can use auto scaling groups. EBS volumes are again the block storage volumes, wherein you can use that volume as an hard drive of your instances. So let's start with fundamentals part 2. And so what is scalability and what is high availability? Scalability means that an application or a system can handle greater loads by adapting. Okay, so scalability means it adapts, the application or your system adapts the greater loads. Okay, and there are two different kinds of scalability. One is vertical scalability and one is horizontal scalability. Horizontal scalability is also called as elasticity, right? So vertical scalability is like, for example, I can give you one example. Like currently you are having one server with you, right? And that server is having your web application or maybe your enterprise application running on top of it. And the current configuration of your server is like 4 GB of RAM and 50 GB of hard drive. But now you see that your server is getting more and more load, and the 4 GB of RAM is not enough for that particular server. So what you need to do is you need to scale it vertically. So vertically means you will go and add more RAM, or either you will replace with a hardware which is having more RAM and more CPU or more hard drive. So that is called as a vertical scalability. And what is horizontal scalability? Horizontal scalability is like you keep on adding more servers, and on top of it there will be a load balancer attached to it. So whatever load which is coming, that load will come to your load balancer, and load balancer will help you to distribute traffic between all the different instances. So we will see all these examples in the live practical scenarios. Scalability is linked but different to high availability. Scalability is again one thing, but it is not exactly a high availability. Scalability, like currently, if I give you an example, currently we have seen in AWS there are multiple regions, and in multiple regions again there are multiple availability zones, right? So scalability, I mean, you can also scale your instances in single availability zones, but that is again not highly available. Why? Because if one single availability zone gets down, your entire application went down, right? So if you want to go and have your application in such a way, or if you want your application to be highly available, so what you need to do is you need to deploy multiple instances in multiple availability zones, so that if one data center gets down, your application still will be served from the different availability zones. So that is called as high availability. So let us see some more examples about it. This is one beautiful example. Vertical scalability. Currently, I have a small in T2 micro, which is having we have already seen, we have already discussed about like having a small server which is not having much CPU, much RAM. And then when there is a need, I have upgraded a RAM and a CPU in that particular server, or change the hardware itself. So vertical scalability means increasing the size of the instance. For example, your application runs on T2 micro instance. Scaling that application vertically means running it on a T2 large instance. Vertical scalability is very common for non-distributed systems such as database. So for database kind of servers, you can use vertical scalability. But if it is having applications or your web applications, for that you can have a vertical. I mean, instead of vertical scalability, you can go with horizontal scalability. RDS elastic caches are the service that can scale vertically. RDS is a relational database service. Elastic cache is again the caching service, where those can be scaled only vertically, that cannot be scaled horizontally. There's usually a limit to how much you can vertically scale based on the hardware limitations. So again, the hardware is also having certain limitations, like we are having, for example, we are having HP server with us, right? And that HP server is again bound to certain limit, that this server can be upgraded to maximum 32 GB of RAM. It cannot go beyond that. What after that? So after that, you need to change the hardware itself, right? So that is something which is a limitation of a hardware. Horizontal scalability. Horizontal scalability means increasing the number of instances or systems or for your applications to cater the load. So here you can see there are multiple people, but you can consider these multiple people as a multiple servers. This I think I have taken it from one of the slides wherein I was also I was also learning AWS. So from that slide only I have taken this picture. In that scenario, what they have considered is like the example of a call center. So currently the call center was having 3 members team and they were handling multiple calls in a day. But suddenly they have seen that there is a spike in a calls and 3 members are not able to cope up with that particular load. So what they have done is they have added more members. So this is something which is called as a horizontal scalability, adding number of more instances or adding number of more people to take care of your incoming load. Horizontal scaling implies distributed system. So this again, it is a distributed system wherein your application will remain on multiple instances, but your backend database or maybe an API, which will be on a different separate instances. So that is again called as a distributed system. This is very common for web application or a modern application. So it is generally used for web application or maybe the application which is designed to work in a distributed manner. It is very easily it is very easy to horizontally scale. I mean, it is very easy when you go and configure auto scaling group or auto scaling targets. It is very easy to scale, right? So it is like configure it once and then you can configure your policies for the auto scaling and you can forget that. It will automatically scale whenever there is a spike in your, for example, spike in your memory or spike in your compute power or spike in your incoming load. So whichever policy you decide, you can deploy that and based on that it will automatically scale. So high availability. So high availability usually goes hand in hand with horizontal scaling. So again, it is a kind of an horizontal scaling. You can consider uh, high availability means running your application in server at least in 2 data centers, or we can call it as a 2 different availability zones. So as we discussed, that if you want your application to be highly available, you need to deploy in such a way that if one data center goes down, your application still should be available from the another data center, or maybe we can call it as another availability zone. So that is something which is called as highly available architecture. The goal of high availability is to survive a data center loss. So as I said, I mean, if data center A went down, your your application will be still served from the data center 2. This again can be taken as an example of a call center. If calls are getting distributed in 2 different call centers, so if one data center fails or one call center fails, all calls can be distributed to the data center B or a call center B. The high availability can be passive for RDS multi-AZ, for example. This can be a passive. In RDS, we can call it as a multi-AZ architecture. So in RDS, you get an option to deploy your database as a multi-AZ, or you can deploy it as a single AZ. Single AZ, it will not be highly available. So if your the region wherein, I mean the zone wherein your RDS has been hosted, if that zone is down, your database will be down. The high availability can be active for horizontal scaling. This can be active for horizontal scaling. High availability and scalability for EC2. Vertical scaling is increasing the instance size, scale up or down. So for example, T2 micro, 1 GB of RAM, 1 vCPU. You can scale it up to U12, UI2 TB L.metal, which is coming with 13.3 TB of RAM and 448 virtual CPU. So this is very huge. So you can go up to this level in vertical scaling. Horizontal scaling increases the number of instances, that is scale out and scale in. So whenever there is a need, whenever you see there is a spike in your load, you can add number of instances. And once the load is down, you can again reduce the number of instances. So that is scale in and scale out. This can be done using auto scaling group and the load balancer. High availability is like run instance for the same application across multiple AZ. So same instances working in two different data centers. Again, this can be used with auto scaling group with multi-AZ. Load balancer again with multi-AZ. So this is what load balancing is. Load balancer are server that forwards internet traffic to multiple servers. So this is your load balancer. All the users are requesting. All the users are requesting, and it is coming. All your traffic is coming to this load balancer, and then from load balancer it is getting distributed to different instances. This is 1, 2, and 3. So whatever policy you configure, it will your traffic will be served accordingly. Use of load balancer is like spread load across multiple downstream. So spread your load across multiple instances. Expose a single point of access DNS to your application is like there will be one single point wherein you can point your web application, that is your load balancer IP or load balancer DNS name. So that DNS name will be actually used for accessing your application, not the DNS name of your instances. So all your traffic will be coming to your load balancer DNS, and then DNS will forward that traffic to a respective instances. Seamlessly handle failures of downstream instances. So for example, if your backend instances are down, so load balancer will take care of that. Like if it will keep on going checking your health of the instances in the backend. And if the EC2 instance health is bad, it will not send traffic to that particular EC2 instance. So we will see all these examples in the live practical. Do regular health checks for your instances. So it will keep on checking regular health check whether that instances is taking the request or not, whether it is up or running or not. So it will keep on checking. Provide SSL termination, that is HTTPS for your website. So if you want your your website to be HTTPS, then that HTTPS termination needs to be done on load balancer end, not on the EC2 instance. You can enforce stickiness across the zone. Stickiness, I think it will be a new word for you. Stickiness is like for example, you are hosting a banking application, right? Or any application which is having your user logging in, right? So what happens is like when you use a load balancer, and in below that there are EC2 instances. So what load balancer does is it distributes your traffic evenly to different EC2 instances. So when you hit for the first time, it will go to instance 1. You hit for the second time, it will go to instance 2, right? So your session get expired because your instances, your traffic is getting changed from one server 1 to server 2, right? So if you do not want that to happen, you need to enable stickiness for that, right? So stickiness, what it does, it will stick your traffic to a particular server for at least your transaction to complete, or for specific time period, right? So whatever time you configure, for that time your traffic will be only served from EC2 instance 1, not it will not go to EC2 instance 2. And once the time is over, then when you hit again, it will go to EC2 instance 2. So this is how stickiness works. Separate public traffic from a private traffic. So all the public traffic comes to load balancer, and from load balancer it will have a private traffic to EC2 instance. Why load balancer is required? An elastic load balancer is managed for load balancer. It is completely managed by AWS. We do not have to configure. We do not have to take care of the backend servers. We just need to configure the parameters what we want in load balancer. AWS guarantees that it will be working all the time. AWS takes care of upgrade, maintenance, and high availability. AWS provide only few configuration parameters. So as I said, we only need to, select the parameters for the load balancer, and rest of the things will be taken care by AWS itself. It costs less to set up your own load balancer, but it will be a lot more efforts on your end. So if you go and set up your own load balancer, again, the backend things are very much huge. You need to take care of all those things. So instead of managing your own load balancer, it is suggested that you go and use the load balancer as a service in AWS. It can be integrated with many AWS services. So this load balancers can be used with many different services. So first we will see with the EC2 instances, and then further we will keep on going with the different services as well. Health check. Health checks are crucial for load balancers. It is again one of the crucial thing, because if load balancer do not go and check the health of EC2 instances, load balancer will not be able to know like whether EC2 instance is running or not. And if it is, it will, if the load balancer keep on sending the traffic to unhealthy instance, your website will become unresponsive, or it will not serve the traffic, right? They enable the load balancer to know if instances forward traffics to all the available to reply your request. So as I said, it keeps on checking, and whichever server is healthy, from there your request will be served. Health check is done on a port and a route. So health check can be done on a port number, so whatever port you decide on that, or it can be done on a route. I mean, for example, you create one file. I mean, you configure one HTTP server, right? And you configure one file, health.txt. So in that txt file, you keep on checking that health.txt file, whether that health.txt file is reachable or not. If the response is 200, not 200 okay, then the instance is unhealthy. So if the load balancer keeps on checking EC2 instance, if the response request is not 200 okay, then the instance becomes unhealthy. There are different types of load balancer. So for example, there are different, the first one is classic load balancer. This is the version 1, old generation. You can configure HTTP, HTTPS, and TCP. Application load balancer is a new V2 version 2 new generation, and this can work with HTTP, HTTPS, WebSocket. Network load balancer is again a V2 version 2 new generation, and it serves traffic using TCP protocol, TLS protocol, UDP protocol. It is recommended to use the newer generation V2 generation load balancer, as they provide more feature instead of going with classic load balancer. So in our practicals, we will see classic and application both. Network load balancer is again chargeable. We cannot go and use it in free tier. Load balancer can be set for both internal and private, internal and external, sorry. So you can use load balancer for both internal traffic as well as external traffic. Load balancer security group. So we have already seen security group, what security groups are, and we have configured that security groups with EC2 instances. It is one of the firewall, wherein what firewall, I mean, what port number you want to allow. Accordingly, you can allow the traffic to that particular port numbers. So same way, you have to configure one security group for load balancer as well, so that whatever traffic is coming to the load balancer, we have to allow that. So for example, HTTP, HTTPS traffic will be coming to your load balancer. So for that, we need to allow port 80 and port 443, and that needs to be allowed from anywhere, right? And from load balancer to EC2 instance, what we need to do is we need to have, there will be one security group EC2 instance. So that security group we need to map it here. So here you can see application security groups allow traffic from a load balancer, right? So in application security group, I mean this security group, we need to allow this load balancer security group. So this is a mapping. So we will see all these things in practical. When we do practical, you will get more understanding and more clarification. Some of the good to know things: load balancers can scale automatically, but not. Sorry. Load balancer can scale, but not instantaneously. What it means is it cannot it cannot scale automatically. So if you think that there is going to be a huge traffic coming into your load balancer or to your application, you need to contact AWS so that they can warm up the load balancers. So warm up is one of the feature wherein you need to raise a request with AWS, and based on your request, they will make sure that the configuration is up to the mark wherein it can serve your traffic accordingly. Troubleshooting of load balancers or maybe the configurations. For XX error are client induced error. 500, I mean 5XX errors are application induced errors. Load balancer errors 503 means capacity or no register targets. So backend EC2 instances are not reachable. If LB cannot connect to your applications, check your security groups. I mean, if your applications, I mean, if you are hitting the load balancer DNS name, right, and your application is not reachable, that means there might be something wrong with your security groups, or maybe you might have not allowed the security groups properly. So that can be one of the reason, or that can be one of the exam questions as well. Monitoring ELB access logs will log all the access requests. So whatever access coming in, that will be logged, uh, all the requests of Elastic Load Balancer. CloudWatch metrics will give you aggregated statistics, connection counts. So CloudWatch is one of the service of AWS which you can use for monitoring purpose, right? So again, this is not free. There are different options in this. I mean, you can use free versions and the paid one as well. So there are two different options. We will learn when we go further. Classic load balancers, it supports TCP. It works on layer 4, HTTP and HTTPS layer 7. Health checks are TCP or HTTP based. So health check, as I said, we can call port number, or we can have something as a route, or maybe some file to call, right? So that is again a route based. When you configure classic load balancer, it will have a fixed host name. So you will not get IP address of load balancer. You will only get fixed host name. So host name can be like your the name of your load balancer, in which region it is, and after that it will be elb.amazonaws.com. Application load balancer is again, it works on layer 7 HTTP. Load balancing to multiple application across machines, target groups. Load balancing to multiple applications on the same machine. Example, containers. I hope you might be knowing Docker containers or Elastic containers. Supports for HTTP2 and WebSocket. Support redirection of HTTP to HTTPS. So if you want to redirect directly from load balancer, it will help you to configure that directly. IP address must be private. So whatever the backend traffic is, it should be in the private subnet. Application load balancer can route to multiple target groups. So you can create multiple target groups, and you can send the traffic to multiple EC2 instances based on your configuration. Health checks are target group levels. Health check can be done on the target group levels. So in application load balancer, there is a concept called targets. So in targets, again, we need to have certain EC2 instances as a backend. So for example, there are two different target groups, and we have four different instances, right? So in target group one, we have EC2 instance 1 and EC2 instance 2. And target group 2, we have EC2 instance 3 and EC2 instance 4. So in that way, we have two different target groups. So for example, abc.com, all the traffic will be coming, and it will go to target group 1, and the traffic will be served from EC2 instance 1 and EC2 instance 2. Same way we have def.com, right? So that will go to target group 2, and that will be served from EC2 instance 3 and EC2 instance 4. Likewise, routing tables to a different target groups, routing based on the path. So this can, as I said, abc.com/user or abc.com/group, right? So user, it will go to target group 1, groups can go to target group 2. Routing based on the host names in the URL. So it can be based on the URL as well. User.abc.com, again target group 1, groups.abc.com, target group 2. Routing based on the query string or the headers. So again, this is something we need to go in depth, how we need to write the queries, and based on that you can route your traffic accordingly. Same way, when we have classic load balancer and application load balancer, we get fixed host name, and host name can be like the name of the load balancer, region, ELB, amazon.aws.com. So here you can see one diagram. Here you can, client request will be coming from their client IP. It will come to this load balancer, And from load balancer to EC2 instance, it will travel as a private IP. So here you have seen, I mean, the target group which we have seen, like EC2 instance 1, 2, 3, and 4. And this is target group 1 and target group 2. So when the user access this abc.com and this is def.com, right? So the request coming from here, it will go to this target group, or if it is in target group 2, it will go to this, right? And if you go in def.com, it will go to target group 2 likewise. So we will see all these things in practical. Don't worry about this. If you do not understand, you can keep a note of your questions and we will answer your questions as well. Network load balancer. So network load balancer is again one type of load balancer. Network load balancer works on layer 4. It forwards TCP and UDP based traffic to your instances. It can handle millions of requests per second, millions of requests, right? And this is one of the load balancer which is costlier. It is having less latency, less than 100 millisecond, and if you go with the application load balancer, it will have 400 millisecond nearby, right? So this is a difference, and it can handle millions of requests per second. NLB has one static IP per availability zone and support assigning elastic IP as well. So with network load balancer, you can get one public IP, or if you want to assign a static IP to it, elastic IP to it, you can do that. NLBs are used for extreme performance, TCP or UDP traffic. So wherever, I mean, if you are having some heavy workload and where you need extreme performance, wherein you are getting more and more traffic and you want more performance, so at that time you can use network as a network load balancer. So this is not included in AWS free tier. So as I said, we will not be able to do a practical on this network load balancer, but I will show you how to create a load balancer from the console. Network load balancer, this is how it works. So it works on TCP rules or UDP rules, whatever rules you configure. Again, it is on the back end, there will be target groups. So again, as I said, abc.com, def.com. This is configured on port 80. This is configured on port 443. So this works on HTTP, target group 1, HTTPS, target group 2, or both can work on HTTP or HTTPS. Your front end will be your load balancer, and back end will be your target groups or EC2 instances. Load balancer sticky sessions. So it is possible to implement stickiness so that the same client is always redirected to a same instance behind the load balancer. So here you can see one diagram. So whatever request coming in is coming to a load balancer. So client A is request is coming only to EC2 instance 1, right? So it is not going to EC2 instance 2. So same way you can see client B request is coming here and it is going here. Client C request coming here, EC2 instance 2, right? And client A is only requesting to this. So this session is active and it is having a stickiness enabled in it. I mean stickiness enabled here. And that is the reason his session is kept live on this particular instance. The same way if client B is doing something, so his session will be kept alive on this instance. Same way for client C. This works for classic load balancer and application load balancer. So stickiness applicable in classic load balancer and application load balancer, not in network load balancer. The cookie used for sticky session has an expiration date you control. So cookie, this is based on the cookies. So when you access your website or application, it creates a cookie in your system, right? And based on the cookie, it has an expiration date. So when cookies expire, your session gets session gets changed or your backend server gets changed. So suppose let's say the cookie is active for 30 seconds, and once the 30 second is over, client A request coming to EC2 instance 1 will redirect to EC2 instance 2. Use cases is like make sure that user does not have his session data. Enable stickiness may bring imbalance to the load over the backend instances. So suppose let's say if you have enabled stickiness, so it might happen that your client A or maybe the request are flooded only in instance one, and that might create an imbalance or the load imbalance. So suppose let's say EC2 instance one is having more load and EC2 instance is having less load. So that is something which is called as imbalance, right? So this might happen with by enabling in stickiness. Load balancing cross zone. You can also enable cross zone load balancing. Each load balancer instances distribute evenly across a registered instances in all availability zones. So for example, as I said, so if you are having highly available architecture, so you might be having your instances running in different availability zones, right? So here you can see this is my highly available architecture, and this is not highly available architecture. So in this you can see there are instances running in AZ1, AZ2, AZ3, and there are load balancer here, here, and here. So in all the three regions we have load balancer. So whatever traffic is coming in, it is getting distributed in different availability zones. And here you can see there is one load balancer, this load balancer, and this load balancer. It is sending traffic to the same availability zone. It is not distributing in different regions or different availability zones or different data centers, we can call, right? Otherwise, each load balancer node distributes request evenly across the registered instances in its availability zone. So it will distribute in its own availability zone. So it will distribute traffic in AZ1 only. This will do in AZ2 only. This will do it in AZ3 only. So we need to enable cross zone load balancing to have load balanced in multiple availability zones, right? Classic load balancer. In classic load balancer, cross zone load balancing is default by default disabled, and there are no charges for inter AZ data if enabled. So if you enable cross zone load balancing, there will be no extra charge for that, but it is disabled by default. You need to go and manually enable that. Application load balancer, it is always on, it can't be disabled. So it is always on, you cannot go and disable that. And there is no extra charge for having inter-region availability zone or cross zone load balancing. Network load balancer, again, it is disabled by default, and you have to pay charges for inter AZ data if enabled. So whatever data is being transferred between inter-region, you have to pay for that particular charges. So network load balancer is very rarely used where you need very extreme performance, and maximum you can go and use application load balancer, which is the latest generation version 2, and this is a very good load balancer. SSL and TLS. An SSL certificate allows traffic between your clients and your load balancer to be encrypted in transit. So if you terminate SSL certificate on load balancer, so what it does is it will encrypt your traffic, which is happening between your client and your server. So whatever in flight, uh, so whatever traffic is going in flight, so that will be encrypted, right? SSL refers to secure socket layer. It used to encrypt the connection. I hope this is very well known. I mean, it is secure socket layer and it is used to encrypt the connection. TLS refers to transport layer security, which is a newer version of SSL. So nowadays we don't use SSL because again it is having many vulnerabilities. TLS is one of the secured channel and which is a newer version. And nowadays TLS certificates are mainly used, but people still refer that as a SSL certificate. We get TLS certificate, but people still call it as an SSL. Public SSL certificates are issued by the certification body, certification authorities. The authorities like Komodo, Symantec, GoDaddy, and various different players are there. SSL certificate have an expiration date. So whatever certificate you buy, it has an expiration date to it. Load balancer with SSL certificate. Load balancer uses X509 certificate, which is SSL or TLS server certificate. You can manage certificate using ACM. ACM is one of the service in AWS, which is called as AWS Certificate Manager. From there also you can buy certificates, or if you want to have your own certificate from different, for example, GoDaddy or Symantec or Komodo, you can buy it there, and you can also upload that certificate to ACM or to your application. HTTPS listener, you must specify default. I think there is some spelling mistake. You can add an optional list of certificates to support multiple domains. So if you are running multiple domains, you can specify multiple certificates to it, or you can buy a wildcard certificate and you can use wildcard certificate to host multiple domains. Client uses SNI, that is server name indication, to specify the host name to reach. So suppose, let's say, if you go and access abc.com, right, and you have the certificate attached with abc.com, right, so that will take that certificate and your request will be served, right. And if you go and access another website which is called def.abc.com, again it will have a different certificate, or if you have the wildcard certificate, then it will go and use the same certificate. If it is not a wildcard, then you can generate a different certificate for that secondary domain, and that certificate will be used for that particular transaction. So that is, again, it is based on server name indication. So whatever server name you have, it is based on that particular indications. So here you can see with the example, SNI solves the problems of loading with multiple certificates onto one web server to serve multiple websites. So this solves the problem wherein if you are hosting multiple web servers in a single server or single hosting, right? So at that time you can have this kind of SNI enabled. So it is a newer protocol and requires a client to indicate the host name of the target server and in the initial handshake. So for example, this is your client, and it is requesting www.mycorp.com. So the request is coming to application load balancer. It will go and check for that target group, and with that target group, it will go and also check SSL certificate and take that certificate and serve your request. So it will use the correct SSL certificate. So if it is going to mycorp.com, it will go to mycorp. It will take this certificate and serve your request. And if you're going with a different domain like domain1.example.com, it will take this certificate and serve your request. Server will then find the correct certificate. So it will again find the certificate properly, and based on that certificate, it will serve your traffic. This only works for ALB and NLB. So this works with application load balancer and network load balancer. It does not support classic load balancer. So this can be one of the question. Classic load balancer supports only one SSL certificate. Must use multiple load balancers for multiple host names with multiple certificates. So if you are hosting multiple websites, and for that you need to create multiple load balancers, I mean multiple classic load balancers, and you need to attach multiple certificates for multiple domains. Whereas in application load balancer, it supports multiple listeners. So you need to create multiple listeners for multiple domains, and multiple listener will have multiple certificates attached to it. It uses SNI to make it work. That is, SNI we have learned it is called as server name indication. So whatever server name you define in the target group, it will take that certificate and it will serve your request. Network load balancer, again, it is the same, supports multiple listener with a multiple certificates. It uses SNI to make it work, server name indication. So that is it for this. Now we will go and log into our AWS console and do some hands-on practical. Just a second, I need to log in. Amit, quick query.
ના ઓલરાઈટ છે હવે જોઈએ.
આ બધું કરવું પડશે ને તારે, એટલે પ્રેક્ટિકલ કરીશ ને તો જ ખ્યાલ આવશે, નહીં તો બધું
કરવું જ પડે એવું છે.
હમ.
ખાસ તો મારે પોર્ટ નંબર હવે બધા યાદ કરવા પડશે. આ તો આખો ખેલ પોર્ટ નંબર નો છે.
પોર્ટ નંબર તો યાદ કરવા જ પડે ભાઈ.
ને આ પણ કઈ રીતે ઇનેબલ કરવાનું મને મલ્ટી ફેક્ટર ઓથેન્ટિકેશન?
મલ્ટી ફેક્ટર તો તારા પેલામાં હશે ને, આઈએમ માંથી જઈને.
અચ્છા હા, એ પણ આપણે જોઈ લઈશું એમ.
Okay. Okay, so now what we will do is we will create two different instances, and we will create one classic load balancer, and after that we will have one application load balancer, and we will be checking how traffic is going and how it is being served using application and classic load balancer. Right. So for that, what we will need is we will need two different instances to start with. So for that, we will again go and launch instance. We will use Ubuntu, or we can use we can use Amazon Linux only, because we have a script ready for that. Amazon Linux 2. We will go with T2 micro, and here okay, we will create separate two instances, and here we will attach we will go and write our user data script. Here, instead of host name, we will display server 1. This we will copy and paste it here. Next. We will choose the security group which we have created. First security group. In this we have allowed SSH and port 80 and port 80. Yeah. Go and review and launch. Choose our existing key pair. My first instance key pair. I acknowledge I have that. Launch. Now the same way we will go and launch another instance. Amazon Linux 2. Amit, mute kar de. Yeah, so now we will launch Linux instance 2, same Amazon Linux 2 T2 micro. Next, same we will go and add user data script. In this we will write, instead of server 1 we will add server 2. The only difference is that, right? So we will know like request is coming to server 1 or server 2. Next, add storage. We will go with same 8 GB. Next, nothing. We will use the same security group, first instance security group, review and launch. Okay, so here you can see now two different instances are running. We will write here server 1, just for our sake of knowledge, server -2, save. So server 1 is ready, and we will see the IP address, copy the IP address, public IP, and we will check whether it is having HTTP running or not. Yeah, so here you can see it is hello world from server 1. Same way, we will go and check for server 2. It should be hello world from server 2. It is still getting up. Yeah, here it is. So here you can see it is hello world from server 2. So now we will configure classic load balancer first, and then we will configure application load balancer. So here in this section only you will find load balancer section. Here you can go load balancer. Here in load balancer you will get an option of creating load balancer, and here there are different options. Which load balancer you want? Is it application network load balancer or a gateway load balancer? Or there is one more load balancer introduced, that is gateway load balancer. So we haven't seen that, we will see. But for now we will go and do a practical on classic, and after that we will do a practical on application load balancer. So we will create a classic load balancer. This is, see again there is a warning, it is a previous generation, it supports HTTP, HTTPS and TCP. Go and create. We will give it a name, my first CLB. CLB is like full form of classic load balancer. Again it is in a default VPC because we have created our instances in default VPC. We have not used my VPC. Here we need to allow which port, on which port your traffic will be coming. So load balancer traffic will be stored on port 80. Instance, on instance again which port you are going to have your traffic. So again we are running HTTP, so port 80 will be there. Port 80. Assign a security group, and we will create a new security group for this. My first sorry, we will write name ELB security group, and here we will allow HTTP and port 80 from anywhere, right? Next. So here you will see there is one warning. Why it is showing? Because we are using HTTP protocol, and that HTTP is not secure. So instead of that we can use HTTPS, but for HTTPS we will need SSL certificate, and we do not have SSL certificate for now. So we are currently doing practical with HTTP only. Next, configure health check. So for health check you need to create or you can have ping port number 80, or TCP you can have HTTPS, or you can have SSL. So currently we do not have HTTP or SSL. We can go with HTTP or TCP. So we will go with HTTP. Index.html is one of the file which is already there. What time you want? Response timer is like 5 seconds. Interval is 30 seconds. On unhealthy threshold. So if this fails for consecutive 2 times, it will mark your instance as unhealthy. Next, add instances. Now we are having 2 different instances, right? So we will add both the instances. Next, so here you can see there is an option of enabling cross zone load balancing, right? Why it is having cross zone? Because both of them are having, both of them are in a different availability zones. One is in East 1A and another is in East 1B. So for that you need to have enable cross zone load balancing. Otherwise it will not work. It will only serve the traffic only to EC2 instance 1A. It will not go to 1B. Next, name my first CLB. Next, and create. So once you create, your load balancer will get created. Here it is. It will take some time to go and do a health check, and from here you can go and click on your load balancer, select the load balancer, and below you will find all the details of your load balancer. So here you can see what is the DNS name. So with this DNS name you can access your websites. Just copy that. First of all, we will go and check what are all the different things. What is the creation time? What is the hosted zone status? It is currently 0 of 2 service, 2 instance in service. It is still going and checking the health. In which VPC it is hosted? This CLB. Availability zones, which availability zones it is are there. Port configuration, on which port it is configured. Currently, you can see it is port 80 of CLB, and forwarding traffic to port 80 of backend. Backend in the sense EC2 instances. Here you get the option of enabling stickiness, right? So you can edit the stickiness if you want to disable. If you want to keep it disabled, you can keep it disabled. If you want to enable stickiness, you can enable that. So in enabling, again there are two different options. It is load balancer generated cookies, or if it is an application generated cookies. Application is like you can have your application configured in that way so that it can generate a cookie and place it in your customers, or maybe the person who is accessing that particular like web server. If you enable this and using load balancer generated cookies, then you need to provide for how many seconds you want that cookie to be present, right? For if you go and click 30 seconds, so for 30 seconds, if you go and refresh, if you go and hit for 30 seconds, your traffic will be served for 30 seconds from one single server only, and after 30 seconds it will go to server 2. You will see all these things in practical. So currently we will keep it disabled. We will go and check instances. So here you can see both the instances are in service. Health check. If you want to go and make some changes in the health check, you can go and edit the health check again. Listener, there is one listener on port 80. Monitoring, so how many unhealthy host, healthy host, latencies, request count, any errors, 500 error, or sorry, close ELB 500 errors, 400 errors. So all the logs will be available here. All the monitoring data will be available here. Your tags, whatever tag you have given, migrations if you want to have migration from CLB to ALB, you can do that directly from here. Now we will copy this my first TLB, the name. Here you can see how it is named, my first CLB, the name which we have given, and this is again a name, the full name, then which region it is, then elb.amazonaws.com. So this is the entire name of your DNS name of your CLB, classic load balancer. We'll paste it here. See, here you can see I have hit for the first time. It is showing hello world from server 1. When I again go and hit, it should go to server 2. So here you can see it got changed, server 2, right? When you hit again, it will go to server 1. When you hit again, it will go to server 2. So it will keep on changing, round robin, right? One server to server 1, one request to server 1, one request to server 2. So in this way it happens. Now we will go and enable stickiness on this particular CLB. Again, you can go to classic load balancer, and here you can see there is an option of enabling stickiness, right? So we can click on edit stickiness, and we will choose enables load balancer generated cookies. We'll click on enable, and we will select 10 seconds. We will not have more. We will have 10 seconds. Now the load balancer sticky will be present for 10 seconds. Now we will again go to CLB, the web page. We'll try to hit. See, you can see your request will not get changed for 10 seconds. See, I'm hitting multiple times till the 10 seconds gets over. It will not go change it to server 1. So yeah, so 10 second is over. Now your request is coming only to server 1. So again, I will keep on hitting for 10 seconds, and after the 10 seconds it will go to server 2. See here. So I hope this is clear what stickiness is. So whatever session data you are currently working on, it will keep your session data alive on particular server, and after that it will route your traffic to a different server. So this can be configured from your application or from your load balancer, or you can have the caching server enabled. So from that caching also you can have this stickiness from there. So I hope this is clear. This we have configured multi-AZ CLB, wherein your backends are distributed in different availability zones. Cross-zone load balancing we have checked. Now we will go and remove this application load balancer, and we will go to we will go and create a application load balancer. So I will select, click, and click on delete, and yes, delete. So that is it. We have removed the classic load balancer and we have done the practicals. So whatever questions we have, we can take it after this. Target groups, and now we will go and create application load balancer. So for that application load balancer, we need to have target groups, right? So first we will go to load balancer, create load balancer. Here there is an option of application load balancer. We can go and click create. Now here you can name it my first ALB, that is application load balancer. How you want it, it should be internet facing or internal. So currently we are having internet facing application, so we will be using internet facing. IP address, what do you want? I mean IPv4 or dual stack. IPv4 we will choose IPv4, or dual stack is like IPv4 and IPv6 both. Listener, currently we'll keep it as HTTP port 80. Availability zones, in which availability zones you want, I will select only two for now, 1A and 1B, because in 1A and 1B only we are having instances up and running. So for now we will select 1 and 1B. The other things, these are the additional option services. Global escalators, if you want to have something boost up, you can have global escalator. We'll go and select next, configure security settings. So again you will get the warning that we are using HTTP, it is not secure. You can go and use HTTPS instead of that. Next, configure security group. We will choose the same security group which we have created for CLB. Select the existing. So this is ELB security group. Next, now we will create a target groups. Target group we will give my TG. My TG is like target group. The traffic should be going to instance, it should be going to IP address, or it should be going to a Lambda function. So wherever you want to redirect your traffic, you can select that. So currently we are redirecting traffic to the backend EC2 instances. So we will select EC2 instance. And on which protocol the traffic will work? The traffic will be served on backend port 80. So we will select port 80. If you are having HTTPS, then you can choose HTTPS 2. So here you can select port HTTP and port number 80. Protocol version is HTTP 1. Health check, on which health check you want, index.html. I will choose this. Protocol HTTP. Advanced health check settings, if you want to make some changes in this, you can go and make the changes. On which port you want, traffic port or override, and the threshold, if you want to go and change the threshold, you can go and change the threshold. Register a target. So in target we can select that there are two different instances. I am choosing and adding it to the registered instance. Just select that and click on add to registered. So this instance will come here. Next, review. Once review is once all the settings are okay, then click on create. So here you can see your successfully created a load balancer, right? We will close this, and here you see application load balancer and the ARN. So there was one question about ARN, right? So this is the ARN. This is a unique name of your service. So this is called as ARN, and this can be used for assigning permissions. Now this is a DNS name. So in CLB also we get a DNS name. In ALB also we get a DNS name. We do not get IP address. And if we go and configure NLB, that is network load balancer, so in that we get IP address, a public IP address, or even you can also assign the elastic IP address to NLB. So we will copy this, or we will first see whether everything is okay or not. We'll go to listener. Listener is okay. Monitoring. Okay, things are okay. If you want to have some settings, and the target group which we have created, we can also go and check that whether my target groups are having health check okay or not. Just click on target groups, go to the target group which we have created, and here we can see the targets. So it is status is still initial, and it is still going and checking the whether the targets are healthy or not. So once these are healthy, this becomes healthy, then only your traffic will be served on this particular instances. So we have to wait for some time to get this instances healthy. We will try to hit once whether it is accessible or not. So see, you can see here, you can see it is still not accessible. Yeah, now it is accessible. So it is still initial, but your traffic is getting served. Here you can see again the same thing is happening. When you hit and hit again, it will keep on changing the server, right? So one request is going to server one request is going to server two, right? So this is what happens when you configure ALB and your traffic and your load getting distributed to two different servers, right? So this is how it helps for managing different loads using load balancer. Same thing you can enable here as well, enable stickiness so that your request will only be served for a fraction of minutes or whatever time you configure from one single instance, and after that it will go to instance 2 or instance whatever you have, right? How many number instance you have. So this is how you can configure ALB. See, you can see here, you can see that status is healthy. Why? Because we have given a health check to it, and health check is like we are pointing one index.html file, and index.html file, if we go and remove index.html, right, so that server becomes unhealthy. So I can show you that as well. We will try to access one of the server. We will go to instance. Let's example server 2. I will go and click on connect. I will connect using this EC2 instance connect. Okay, so now we are in server 2. We will change the privileges, change the user, sudo u su cd/var/wwe html. Now here you can see there is one index.html file, right? I will remove this rm-rf index.html. So now there is no file here. So now within some time you will see that the instance 2 will become unhealthy. Why? Because there is no index.html file. Go to EC2 instance. Target group. Click on target group. See here, you can see the health status of server 2 becomes unhealthy. Why? Because we have removed index.html file. And here you can see that instead index.html file is continuously being checked to check the status whether your instance is healthy or not. So whatever file you configure, that should be present all the time to make your keep your server healthy. If you remove those files or if you change the configurations, your instance will become unhealthy and your traffic will not be serving from that particular instance, right? So currently if you go and hit this, your traffic will only getting served from server 1. It will not go to server 2. So what I mean you can keep on hitting, all the traffic will be coming to one instance only. So this is how application and classic load balancer works. I hope this is clear. We will now go and remove this load balancer first, so that there should not be any kind of a billing. Click on this load balancer. चल भाई क्या हो गया? I will go and remove the target group first. Delete. Okay, the listener is in use. Okay. Okay. Click on delete. Yes. So this will delete your load balancer. We can go and delete the target group. So there is nothing. So once you are done with the practical, make sure you delete whatever you have done. Otherwise, if you keep on lying, if you keep it lying, then you might be getting charged for that, right? So just make sure that you go and delete everything. AMI which we have created, I think I have forgot to delete that. I will delete that as well. Yeah, there is one AMI. Deregister, continue. Okay, that is it for today's session, Amit. Any questions you have?
As I see, there is a classic and applications. I think both are the same. I don't know why applications and classics are different.
See, application works differently, classic works differently. So we have seen there is a difference in behavior of those, right? So I will show you a slide. See, application classic load balancer works on HTTP, HTTPS, and TCP, whereas application load balancer works on layer 7 only, HTTP and HTTPS. It does not work with TCP, right? So this is a difference, okay? And in classic load balancer, you have to create, if you are hosting multiple websites, then you have to create multiple load balancers. I mean multiple load balancers. Suppose let's say હમણાં તું હોસ્ટ કરે છે abc.com, બરાબર છે? તો એના માટે તને અલગથી ક્લાસિક લોડ બેલેન્સર જોઈશે. Then you are going to create one more website, right? That is def.com. So એના માટે તને અલગથી લોડ બેલેન્સર જોઈશે. અને પેલામાં શું થાય કે એપ્લિકેશન લોડ બેલેન્સર જ્યારે તું બનાવે તો એપ્લિકેશન લોડ બેલેન્સરમાં you do not need to create multiple load balancers. તો આની અંદર તું ટાર્ગેટ ગ્રુપ બનાવી શકીશ. એટલે આપણે અત્યારે એક ટાર્ગેટ ગ્રુપ બનાવ્યું, બરાબર છે? ફોર એક્ઝામ્પલ તને બતાવું.
For application load balancer.
TG1 પણ અત્યારે મેં ઇન્સ્ટન્સ ડિલીટ કરી દીધા. હવે મેં ટાર્ગેટ ગ્રુપ અત્યારે આપણે બે ઇન્સ્ટન્સ બનાવ્યા છે, બરાબર છે? તો આની અંદર મેં શું કરીશ કે બે ટાર્ગેટ ગ્રુપ બનાવીશ, અલગ અલગ ટાર્ગેટ ગ્રુપ. હા, તો જ્યારે ઇન્સ્ટન્સ એડ કરીશ ને તો એમાં ઇન્સ્ટન્સ બે અલગ અલગ ટાર્ગેટ ગ્રુપમાં બંને અલગ અલગ ઇન્સ્ટન્સીસ હશે. સો ફોર એક્ઝામ્પલ ટાર્ગેટ ગ્રુપ 1 ની અંદર ખાલી EC2 ઇન્સ્ટન્સ 1 હશે, ટાર્ગેટ ગ્રુપ 2 ની અંદર ઇન્સ્ટન્સ 2 હશે. સો એવી રીતે તું મલ્ટિપલ ટાર્ગેટ ગ્રુપ બનાવી શકીશ મલ્ટિપલ વેબસાઇટ્સ માટે.
ઓકે, ઇટ ઇઝ ફોર ક્લાસિક.
ધીસ ઇઝ ફોર એપ્લિકેશન.
ઓકે,
એપ્લિકેશન એવું છે. તું કાલે આપણે ફરી એકવાર આ કરીને જોઈ લઈશું.
હા, યસ
ફરી બતાવી દઈશ.
એકચ્યુઅલી મને પ્રેક્ટિકલમાં તો બંને સેમ જ લાગ્યું. અત્યારે આપણે જે પ્રેક્ટિકલ કર્યું ને એમાં મને સેમ જ લાગ્યું.
હા, તો કાલે એક કામ કરીશ, તને કાલે ફરી પાછું એકવાર બતાવી દઈશ. આપણે ફરી પાછું ક્લાસિક લોડ બેલેન્સર ને એપ્લિકેશન લોડ બનાવીને જોઈ લઈશું. અને બે ઇન્સ્ટન્સ જગ્યાએ આપણે 4 ઇન્સ્ટન્સ બનાવીને જોઈ લઈશું, બરાબર છે?
ઓકે, ડન. નો પ્રોબ્લેમ. એક તો કાલે હું એકવાર પ્રેક્ટિકલ કરીને જોઉં ઓફિસે શું ડિફરન્સ છે, પછી જોઈએ.
સારું.
ઓકે. હા,
બીજું કોઈ ક્વેશ્ચન?
ના, બસ આ જ હતું. અને વર્ટિકલ સ્કેલિંગ ઇઝ ઇક્વલ ટુ લિમિટેશન એન્ડ હોરિઝોન્ટલ વી કેન ગો અહેડ.
વર્ટિકલ સ્કેલિંગમાં તું હાર્ડવેર લિમિટેશન આવી જાય ને કે ભાઈ તારો હાર્ડવેર જ એટલું સપોર્ટ નહીં કરે તો પછી કેટલું વધારીશ.
યસ.
અને હોરિઝોન્ટલમાં તું કે નંબર ઓફ ઇન્સ્ટન્સીસ વધારવાનો છે. તો
ઓકે
EC2 ઇન્સ્ટન્સ એટલે T2 માઇક્રો અત્યારે યુઝ કરે છે, તો T2 માઇક્રોનો તું 10 બનાય, 15 બનાય, 20 બનાય,
હા
એની કોઈ લિમિટ નથી.
ઓકે
જેટલા તું બને છે એટલા ચાર્જ લાગશે, બસ એટલું જ.
ઓકે ઓકે ડન, સમજી ગયો.
કામ નહીં
જા
કરતું
દીદી
ભાઈ.
બોલાવે છે.
છોકરી છોકરો?
હા ભાઈનો છોકરો છે, મારે છોકરી છે.
અચ્છા.
હા જાઈને ઉપર લઈ જા. કઈ નહીં તો કપિલભાઈ કાલે આપણે ચેક કરી લઈએ એકવાર. હું સવારે કઈ તકલીફ પડે તો જણાવીશ.
ઓકે ભાઈ,
હા ને?
ઠીક.
હા
હા,
હા
ચાલો.
ઓકે હા ચાલો ગુડ નાઇટ.